Welcome to this I2K 2022 workshop on 3Dscript. My name is Benjamin Schmidt, and today I would like to show you how to visualize and animate microscopy data in detail using 3Dscript to create videos like the one shown here. And not only how to do that locally on your computer in front of you, but also how to do it remotely on a dedicated processing workstation. So let's dive into it. I will start my image J, and I open one of my sample images which I want to use for this workshop. What you can see in this image is it's a light sheet dataset. It was acquired on a LaVision Ultra microscope, and it shows a mouse paw. There are 3 channels. And before we actually go ahead and start 3Dscript, I will quickly adjust the brightness and contrast. This is highly recommended to do before starting 3Dscript. And so I will quickly go to Image, adjust brightness and contrast. And I will also open the Channels tool. And so let's quickly adjust this. Just to have a good starting point. So the second channel is quite dim. But I also would like to get actually rid of some of this background here, so I will actually increase the minimum a little bit. Maybe be something like this. And the third channel is actually quite weak, so you can see that the signal is very noisy here, so this gives me a harder time to adjust it well. But I think this should work nicely now. And so let's put this to the side. And now we are ready to open 3Dscript. And right now I will use the interactive animation plugin, and I will just open it up, and once it's loaded you can see there's one 3D preview, an interactive preview window, and there's another window popping up which basically gives us a chance to adjust all the parameters, or the rendering parameters, which specify what we actually see here. So this preview window is interactive. You can rotate your sample by dragging with your left mouse key. You can move your sample around by pressing the Shift key, and you can zoom in and zoom out. And so now what I would like to do in the first part is we'll go through this second window here and see all the parameters so that you get a good overview of what is possible in 3Dscript. You can see that this window is subdivided into several panels. Most of them are actually hidden at the beginning to not overwhelm new users, and only the first one is shown. And that's also where we will start now, and maybe we will start with these sliders here. So these give each channel a weight, so there's one slider per channel, and we can just linearly fade in and out each of these channels. We can also double click these sliders and change the color. So we can make this first channel, which by the way is autofluorescence, show in a different color. We can also select this background color icon here and change the background of the view if we want. And by the way, there's always a reset button which will bring us back to where we started from. There are a number of 2 major rendering algorithms here. And one of them is independent transparency, and the other one is combined transparency, and they will very much affect what our outcome looks like. And so by default the independent transparency is selected, and this means that the different channels, the opacity of the different channels will not affect each other, and so we can look through each channel basically. The opposite is combined transparency, where the opacity of one channel will actually affect the other channel. You see what this looks like. So in my eyes this looks a little bit more realistic. It's like in real world you can't see through something opaque, but of course it depends what you want to visualize, whether you need to look inside or not. For now, let's stick with the combined transparency. And so now there are a number of parameters which we can adjust to really fine-tune what we see here. And we'll start with these numbers here, which is the minimum and maximum for brightness. So in a way this is the same as adjusting the contrast in Fiji or ImageJ. And you can also see that the numbers that 3Dscript uses here by default are the same numbers which ImageJ uses for the brightness and contrast, and that's also why I said it is highly recommended to adjust the brightness and contrast before we open up 3Dscript. Okay, so you can see we have this minimum and maximum as we have it in ImageJ, which basically means we define our black point and we define our white point, basically translation from signal intensity to brightness. And in ImageJ there's a linear relation in between, so if we have an intensity which is somewhere in the middle, we'll get a gray value from linear interpolating between the extreme values. In 3Dscript there's another value here which is a so-called gamma values. You can also see when I change it now on the curves here. So if I make this gamma value smaller than 1, the midtones will be emphasized and they will get brighter. If I make this value larger than 1, these midtones will be suppressed and these pixels would become darker. Now for 2D that's fine and sufficient, but in 3D each pixel also needs some kind of transparency so that we can actually look through it. Otherwise we would just see basically a block which would most likely be black. And if you think about it, it completely makes sense to make the opacity also transparent of the signal strength. So the higher the intensity of a pixel, the more opaque it should be, most likely, and the lower the intensity, which at least in fluorescence microscopy means we are most likely in background, and in that case we would like it to be more transparent. So in a way we have a second function like the contrast, but this time not affecting the brightness but the transparency, and this is what you see here under alpha. So again we have a minimum value which again is taken from the contrast adjustment which we did before, and a maximum value, and again we have a gamma value where we can define how the midtones are rendered. The gamma value is by default set to 2. In many cases this just looks nicer, but there's nothing which stops you from actually changing this. And so my recommended way to go about this here is that you, as I told you, initially adjust the brightness and contrast, and then once you opened up 3Dscript, it's probably not necessary anymore to touch the minima and maxima, but just get a quick adjustment by changing the gamma values. Now these values are here per channel, so we can go to another channel here and do individual settings for the second channel and for the third channel, of course. And in case you got lost, and as I mentioned, there's this reset button so that you can start over again. And then there's one more option that I would like to show you here under this contrast panel, and that's light. So I selected the first channel, and I enable light, and light means that the appearance of this channel will get we'll see some shadows, and these local shadows will give the impression of a real solid surface, as you'll see in a second. So the light has different components. Object component is the object itself as we defined it up here. And then there is a diffuse component, which is just light coming from anywhere, no direction. And then there's specular light, which will then give these tiny reflections, which let's maybe just see what this looks like. So we'll just increase the diffuse color, and you see the effect. It gets a little brighter because we're adding light, but at the same time you also see these local shadows. And now we can add some directional light. Let's slowly add it maybe to 1. So now you see quite some light. The shininess basically affects the specular light, and you can just play with this. So this will distribute the light a little more, and I think that looks actually quite impressive and fits very well to this image here. However, I personally would like probably to have this first channel, which, as I mentioned, is the autofluorescence. So it's kind of a reference channel which gives us the context of the sample, and most likely we would like to have this a little bit transparent so that we can actually see what is inside. And so what do we need to do to get this channel more transparent? So you can see the opacity curve in blue here, and right now it's fully opaque at the end. And so we will just make sure that at the right end here we will have a value which is actually not the maximum here, so which is below. And so maybe we'll first start and bend this curve upwards, so which means it gets basically more opaque. And now by just increasing the maximum, and I will just add some zeros here, you can, if you watch this blue line here, you can see as this moves down here, so we'll add more. And at the same time you can see, if you look at the rendering here, that the outcome gets more transparent. So something like this I think looks very nice. It helps to have the light still on because we see some texture actually. So you can see now when I remove the light it looks rather flat, which might also be fine, but if we enable it we see some of the surface cues here, which is quite nice actually. So I like this setting a lot, so I will show you, I will quickly make a detour to the bookmarks panel, and so I click on show, and the bookmark panel basically keeps bookmarks, so saved settings. And a bookmark, basically I will add it by clicking on plus here. A bookmark will contain all the settings which we made, so the transformation, but also the channel settings and everything else. You can give it a name, so like this maybe, but doesn't need to be. And there's also, you see, a home bookmark, which is the initial state where we started from. And so you can switch between the two. You can also save bookmarks to the hard drive and load them again, and you will immediately end up at the state which you saved basically. Okay, for now I would I think I go back to my initial state. Still I would change the background to white again. And we'll use that. So this is it basically about the contrast panel, and let's now quickly look at the other panels that we have here. There's not so much surprise here, so there's just the current transformation which we are looking at, and you will see as I interact with the preview you see these values here for rotation, translation, and scale being updated. You can also change these transformations in these fields here. You can reset it to the default, and you can also scale, of course. Then there's cropping, which is probably more interesting. And so basically you can crop your data from all different directions. So we can, for example, crop it from the left-hand side. These are double slides, so we can slide them from both sides. And we can crop in along the X direction, along the Y direction, and also along the Z dimension. And in addition to that, we can also crop parallel to the screen, which then looks like this. And so now this depends on the transformation. So this, what we see, this cross-section that we are looking at, depends on the orientation that we look at, which sometimes might be a little bit confusing, but the effect is that we can actually look at an oblique plane, which is sometimes exactly what you need. And then the entire cropping does not need to be done on all channels simultaneously, but we can just untick this apply to all channels box, and now we can crop individual channels away. The channel which is cropped away is the channel which is selected up here. So right now this is channel 1, and that's why we remove this first channel here when I move the slider. We have seen the bookmarks panel, so I don't need to go into that anymore. There's the output panel where we can specify how big the rendering is, so in terms of pixels. By default, 3Dscript uses the size of the input image, not the input image actually, but the window. And if I zoomed out to 75%, then this window will be adjusted accordingly. But you could change these numbers here if you want better quality rendering, maybe for a still in a paper or something like this. Then there's a bounding box, which is this frame around the object, and you can click it away if you don't like it, or you can change its properties like the line thickness and the color. And then there's a scale bar, which you actually don't see right now because it is white, so it would be down here on the left hand side. So also the scale bar can be hidden by clicking it away, or we can change its properties. So maybe let's first make it black so that we can actually see it. So here it is. We should probably make it a little longer, maybe 200. You can change the line width or the offset, which is the distance to a corner, and you can also attach it to the object itself, which then would look like this. So it's attached, and which has the advantage that it's a three-dimensional scale bar, so to say. But for now, let's just leave it at the lower left. Okay, that's the output panel, and then what's left is the animation panel. And so there's only a button here, and when we click at it, we get this dedicated editor, which we will use for making animations. This is the next step now. You have basically seen now all the features that the 3Dscript renderer provides. And the good news is that you can basically animate all of these numbers, which you can change here, over time, and creating effects from it and animations. And the way you do this in 3Dscript is basically by telling the software in English sentences what you want to animate. So this is actually the major motivation behind developing 3Dscript. There are different approaches. The most used one is probably based on keyframes. In 3Dscript, you create animations by telling the software in sentences. So what does this look like? Let's start with a simple example, and let me just move this we can actually hide this one and move the preview to the left and have this in the middle. So let's just start with a simple example maybe, and so this will also show you that you don't need to remember anything if you use it. So just remember typing F. So I type F and everything else will be auto-completed. And so I now need to enter something, namely a frame number, and frame here means the frame in the video which we will create. So we'll start at the beginning at frame 0 and I hit space, and you can see that the editor again auto-complete as much as it can. And now we need to give an end frame. So let's say we do something within 100 frames. Again I hit space and now you can see there's more auto-completion, and for now I will just use the rotate here. By I need to enter a number for degrees. Let's just do one full rotation. And then we need a direction, and we'll just do horizontally right now. And then the last bit is we can select one of these keywords here. None or linear means we will have a linear motion, so constant speed all over the animation. Ease in out means we will start slowly, it will accelerate towards the middle, and in the second part it will slow down, which gives more smooth transition. There's ease in, which will accelerate at the beginning but end linearly, and ease out the opposite, so start linearly and end slowing down. And ease, which is similar to ease in out, it just uses different parameters. So let's just use ease maybe for now. And once I have such a sentence, so this is now one instruction, I will also call it instruction from now on, we can animate this, and we do this by clicking on run here, and you can see so the speed with which this is displayed now is actually the speed at which it can render, so it depends on your graphics card mainly. It's not the speed of the video. And now we get this new window here, and it's basically a normal image Fiji stack window, and you can animate it by clicking on this play button here, and now you see at which speed it will actually play when you save this as a video file. Okay, so it works. Now let's do more with it, because this is now not very exciting yet. So we can now just go ahead and add more sentences, more instructions. So let's do this. Let's say from frame 0 to frame 100. So we're using the same frame interval. And this time let's zoom in. Zoom by a factor of maybe 1.5. And let's use the same ease. So you see now when I am typing this, the auto-completion makes it really fast, so it's really very convenient. Now we have a second sentence, and both happens at the same time. So what we expect is a video where we rotate and zoom in at the same time during 100 frames. And let's run it and just confirm this. And you see this is exactly what's happening. And now when we have several consecutive instructions which act in the same frame interval, we can also write this in a nicer way as a list or enumeration or whatever you like. So basically we write the frame interval, we end it with a colon, and then everything which comes afterwards starts with a dash, so like this. So this will do exactly the same thing, but it's slightly more readable and also easier to type. Let's just confirm, so this still works. By the way, if you're running something and you realize that it's not what you expect, you can always kill it. You don't need to wait for the full video to render. I guess we'll later have use for that probably. Okay, so let's add more stuff to make this more interesting. This time let's maybe start at a different frame. So we could maybe start at frame 50 and go up to frame 120. And so let's see what else can we do. So we have seen the rotation, we can translate, we can zoom in, We can reset the transformation, which is more like a helper function. We'll see that later. And we can change. And change is basically everything that we have here. So there are different kinds of parameters, channel-specific parameters. That's what we have here. And then we can change these channel-specific parameters either per channel. That's the first item. We'll see that in a second. Or we can change these parameters for all channels simultaneously. Then we would use this one. And then there are global parameters which do not depend on a channel, so they are global. For example, a background color or the time point in case you're animating a time-lapse dataset, or the rendering algorithm which we had here, and so on. So for now, let's pick a channel property. Let's say we want to change the channel, and let's say channel 1. And so what can we animate? And when you see this list here, you will probably realize the relationship between the user interface and these names. So min intensity would be this number here, max intensity this number here, gamma is here, and so on. So you see there's really one-to-one relationship, and you can animate basically each number that you find on the right-hand side. What I would like to do right now is I scroll down a little, so the bounding box is basically the cropping, and I will choose in Y direction, and we will crop it. So let's maybe just have a look here. So the X range goes to, the Y range goes to 853, so maybe we just use 800 right now. And let's see what this looks like now. So we get the rotation, we get the zoom in, which we still have in our script, and then somewhere at frame 50 it starts, and the first channel is cropped away. This is just what we basically wrote down here. So it's what we expect. What you might not expect is if you run this again now, there is actually no channel 1 anymore, so it doesn't fade away because it's also not there from the beginning on. And the reason here is that the initial state, so where this animation starts, is in the current state which we have here in the user interface, and which we also see here in the preview window. This is of course we can now of course manually resetting this cropping slider here and run it again, but this is not so nice because we don't want to do this each time we run it again. So there's a nicer way to do this, and I will show you how. Basically, I'm going at the beginning of this text here. I make some space. And now what we can do is we can insert at the beginning some instruction to reset it. And now I told you should remember F. Another letter to remember is A, so that's not from frame but at frame. And we can say at frame 0, so right at the beginning of the animation. We change. Basically I can copy it from here. Channel 1 bounding box, but we reset it to 0. So this will work. I will not show it actually. I guess you believe me that this will work. But I would like to show you that there's another way to do this, which may be a little bit more convenient. So I will remove this line again. And I will actually go once more in the user interface. I make sure that the cropping is reset here in the user interface, and then I can automatically insert these instructions by going to record. And we'll see these functions later, step by step. But right now I choose record cropping. And so this will automatically insert all the instructions which are necessary to bring the animation to a state which is displayed in the GUI. So which in our case now means all these slides are reset. I just need to enter a number for the frame when this should happen. So at the beginning I will enter frame 0. And now something that's a little not so nice is that we have now quite some text which might confuse, and so there's also folding capabilities of the editor which allows us to hide this in case we just want to blend out and not get confused by it. but of course we can also have it there. And so now when let's just confirm that everything works as we expect. So I run this again, and you see we get the rendering. The channel 1 is here, and it is cropped away during the animation. And when I run it again, it still works. So no need to manually reset anything. Okay, so let's try the kill. Kill also works, and let's close this. Now there's some issue related to this initial state problem, and so right now we always started. So let me reset this so that it looks a little nicer. Now all our animations started from basically the identity transformation, so with the untransformed object. What if I want to have the object rotate with this starting orientation? So can I just do it? I click run. No. So it always starts from basically the untransformed object. So that's different from all the other numbers that you animate. The transformation always starts from the identity, no matter what there is in the user interface or at the preview. So how can I still use some different starting position? I will of course show you. And so basically let's choose a nice starting position. So let's reset it, and let's say we would like to start from somewhere like this. And so I go somewhere in this text where maybe after the cropping. And now I will again go to record, and this time I'm not choosing record cropping but record transformation. And you see it inserted these lines here, which are basically necessary to bring this object from the identity, so from the untransformed object, into this orientation. Again, I have to tell it at which point in the animation, and we want to do it at the beginning, so I will enter 0 here again. And now let's see if this works. Yes, indeed, it does work. So this is exactly what we wanted to achieve. Okay, so now you have actually seen quite a bit. Maybe one more thing right now. Let me check. So you can see, let's look into this again. So what we see now is that our object that we are animating is first transformed into this initial orientation, and then we do this rotation, which we have here. So we rotate horizontally, which means, I will just play this movie again, it rotates around this global y-axis. And now I would like to this is not really something which is probably not obvious if you don't know it. What if I want to not rotate it around the global y-axis, but around the object's actually the x-axis, so the axis which is pointing in this direction here. But so perpendicular to this object coordinate system. Of course, I could now calculate manually where this axis would be and then rotate around this axis. That's not so nice, so I don't expect anyone to do this, and this would be really cumbersome, and I would not want to do it. And so let's just go back to this script here. What we now always did is basically we kept everything in the order in which it happens, so in the time order, let's say. But that's actually not necessary. It doesn't matter from a time perspective where we put things, but the order really dictates the order in which things are applied. And that's particularly important for transformations, because if we want to first rotate around the original coordinate system of the object, we just can do this at the beginning. And let's just see how this would look like. So I will pick this rotation here. I will cut it, and I will move it to the beginning. Actually, we can do it after the cropping maybe. I will insert it. but now we don't want to rotate horizontal, but around the object's z-axis. So I remove horizontally and type A for around, and then I specify the z-axis. And so we now there's one more thing that we need to take care of. So we do this rotation, and then we transform to this initial rotation. But there's one thing here which is actually getting in our way, and that's a reset transform, which will basically take fully away the effect of this here. So, and we don't need it here, so we'll just delete this line here. And now when I run it, you see, you might not actually realize, but if we'll compare it, so it now rotates really around the object z-axis. So here we get this, and here we get this. So it's really a difference. You might not have realized, but this rotates around the global y-axis, and here it's around the object's z-axis. Okay, so we can close it. And now let's maybe do something different. So let's extend this script a little bit and do something nicer actually. So I will keep the cropping recording, but I will hide it so that we don't get confused. We have this rotation here, which I will also comment out. So you can comment out things, and I will just comment out this rotation here. And in particular, I will delete the cropping. And now I would also like to start with a different starting point, so I will delete this one here. And I go back to the user interface. Maybe I also reset the cropping. And so what I want to use as a starting point is I will reset it. Actually, I would like to flip it, so let's turn it by 180 degrees here. And I would like to zoom out a little bit, so something like this. So I would like to have this as a starting point. And so you have seen this already. I go to record and record transformation. And again, this should be at the beginning, so at frame 0. So here we go. And now I show you something else. So now I would like to transition from this state and bend this object a little bit, and you will see how. But the way I do it is different. So I can not only record states, but I also can record transitions, and that's what I want to use now and to show to you now. So before I do the transition, I click on Start Recording Transition. And now I will go here, and I will maybe do it like this. So this would be my end state, and so I go again to record and stop recording transition, and I have to tell the software between which frames. I would like to do this at the beginning from frame 0 to frame 100, so like this. And so this is what it does. Actually, it just rotates a little bit vertically. We could have done that manually, but I also wanted to show you this record transition thing. Okay, so let's maybe just look what it looks like. So exactly, not very fancy so far. And so next I would like to subdivide these 100 frames, and first zoom out a little bit and then zoom in a little bit. So let me just show you. So we say from frame 0 to frame 20. So in the first bit we zoom by a factor of 0.8. So we zoom out a little bit. And then from frame 20 to frame 100, so the second part, we zoom in a bit, let's say by a factor of 2. And again, let's just see what this looks like. So almost as I want it to be. The only thing which I don't like yet is I want it to be not linear, so I will actually do the rotation with this ease keyboard, and also the zooming, like this. So, okay, and let's just do it again to see what it looks like. So here we go. And now, following this first part, I would like to have again the cropping. So I would first crop the first channel away, and then we crop the second channel away. So let's just do it. So after these first 100 frames, so from frame 100 to maybe let's say frame 200, and so now we change. We have seen this before. Channel 1, bounding box min y to 800, why not? Let's just see. So we do the zooming and then we do the cropping. What I don't like so much about the way it looked now is, I realized just now, so this is completely non-overlapping, and that makes it a little bit unsmooth. So I would rather probably, let me just delete some of the windows here. I would start these cropping away a little earlier so that it overlaps with transformation before, and then we can also stop it a little bit earlier, so maybe like this. And then at the same time I will add another instruction where we start from frame maybe 180 to frame 280, and this time we change channel 2 bounding box min y also to 800. And now I would like to get preview, but I don't want to always render the whole video because that gets like time consuming. So I would only like to run the second part. So let's say from frame 80 to frame 280, and I can do that by going to run from 2. It will still take the entire text into account, but only render the frames which I specify. And so I can say 80 to 280. Okay, so this is what we get. So first we cut channel 1 away, and then we cut channel 2 away, and that's where it ends. So following that, I would like to reset those croppings. So I would say from frame 280 to frame 300, change, and this time we do both channels, so we say all channels, bounding box min y back to 0. And so again we could check with run from 2, but I would like to, so the shortcut for this is actually Control Shift R, so we can benefit from this. But if you select some lines, it will automatically define the default frame that is rendered. So when I hit Control Shift R now, you can see it automatically sets it to 80 to 300. Again, it still takes the entire script into account, but only render these frames. And so this is what we get. Again, we have the cropping away. First channel 1, then channel 2, and then they come back. Okay. So now, after this cropping, I would like to do the rotation, and we have it here. So we'll just re-enable this rotation again, as we had it. But we need to change the frames, so we would do that just after this. So maybe from frame 300, or let's maybe again start a little bit earlier. So maybe 280 to frame 380, and again, maybe we just look what this looks like. So again, I select this frame range here and click on the run from 2 and OK. And so we see as it drops back. Okay, I think I missed something. So indeed, I can spot it. So we need to get rid of this reset transformation again, which I mentioned earlier. And so again, let's do this once more from 2. Okay, and this is indeed what we wanted to see. So I think I would get rid of this zooming here. This is too much. Let's quickly check. Yeah, so that's better. maybe let's make it a little bit more fancy. So let's not do one rotation but two. So let's go to 480 then, and let's rotate by 720 degrees. But let's switch in the middle to our saved bookmark. Okay, let's see how we do this. So we can do it anywhere, it doesn't really matter. We can do it at the end here. So add frame 380, so just in the middle of this rotation. Or better, we just memorize this. I will just put my cursor here, and now what we do is we go to our preview window. I go to my bookmarks. Now I click on favorite. Here we go. And now, so we want to record this state, so I go here and I say record contrast. And now you remember it's frame 380. But you see this is quite a bit, and we only changed channel 1, so I will delete everything which is not related and only keep the settings from channel 1. Okay, let's run this again. Too bad. So you see, now we start already with that frame. That's not what I wanted. So I will close it again. And so what we are really missing now is we did not actually save the initial state where we started. I should have done this. So I will just quickly reset it. I will disable the light. We go to reset rendering settings. We use combined transparency, and we enable the cropping. So this is where we started from. I go to the beginning, and so this is really important actually, and I will mention this later, but I would always recommend to record this contrast here. Again, we can do it at frame 0 at the beginning. So just insert a blank line here to make it more readable. So we can also hide this. Okay, and so now let's run it again, and now you see we start with this rendering state that we selected, which we had originally. We do the cropping, we do the rotation, and in the middle of the rotation it should switch. Indeed it does, to this transparent mode, so that we can actually look inside and see in more detail the stainings in this sample. And now the only thing which I would like to do in the end of this animation is I would like to move it to the original transformation, which will just look a little nicer. And so I go to the end, and again I will say start recording transition, and now we can just reset it. So like this, but remember we had flipped it and we zoomed out a little bit, so let's use the very same settings here, and we go to record, stop recording transition, and we do this at the end. So our rotation stops at 480, and so we do it at 480 to 500. So this is our final script now, and I will run it once more. You see, that's everything we had before. We do the cropping of the second channel. They come back, we rotate. In the middle of the rotation it will switch to transparent. And once the rotation is fully done, like now, we'll move it back to the initial orientation. So this is it basically. That's what I wanted to create with you, and I think you saw quite some details. You also see it got quite long, but most of it is actually these recordings which you don't even need to type. So in the end I think it makes all sense, I hope at least. So we can, what I really like now, what I really like most probably about 3Dscript is that I can now just save this script, and let me do this. So let's save this. I will just overwrite the existing one that I had before. And basically it means that whenever I come back and want to recreate this video, for example, I want to change something slightly like a color or something, I can just load this text again and run it again. So in a way it makes creating animations very reproducible, more than it was ever possible before. And I think that's really the key feature which I like most about 3Dscript. Also, just think like you are doing an experiment. You have maybe different conditions or different repeats. You have a number of images which were taken, acquired with the same settings, and you want now to compare them, maybe look out for a phenotype. And so you would like just all of these images to be rendered with the very same settings. And now, since you have the script, you can just open the next image, open 3Dscript again, and just load the text. You don't need to do any adjustments, just load this text and run it again. So I think that's this is really, in my eyes, the key feature of it. But before, so I will talk a little bit about this in a second, but before that I would like to show you actually something else, a new feature actually. And that's oftentimes you might want to run an animation, but you want to see the different channels, so that happens again and again. Let me just get rid of some of these windows here. This is actually quite often the case, and so I automate this, and when you go here to extras, you see some sweet stuff actually, and one of them is render multiple channels. And I would like to show you now what this does. But before I do so, I think since these are multiple panels, we will actually maybe reduce the output size. So let's maybe make it half the size, so 270 times 320. And now let's do it. So I go to extras, render multiple channels. It asks me for the number of panels. I want to have 4 panels. And now I can choose which channels should be on in each panel. So in panel 1, I want to have channel 1. In panel 2, channel 2. In panel 3, channel 3. And in panel 4, I want to have all channels. And the panels should be arranged in one row, 4 columns. And so I click OK. And this will now take a couple of seconds because it's still quite a long animation actually, and it will need to do it for all the panels, but we'll just wait for it. So it does one at a time. Here comes the last one. And so now it's done. Here it goes. And so what you see is now all the different panels placed side by side in one huge, more or less, video. And let's just play this. So I think this is really nice. Of course, if we crop one channel away, it doesn't affect the other panels. But I think this is also still quite a useful feature. Okay. So now I briefly talked about reproducibility, and so I mentioned if you now want to apply the very same rendering to a different dataset, you just need to open 3Dscript again and open the text and then run it. And but since we don't need to do any adjustments anymore, there is a much easier way to do it. Actually, we don't need the interactive raycast at all. So let me just quit it, and also this one, and also this one. But I will just make sure that I have my input image still here. And so now I can, instead of running the interactive version of 3Dscript, I can use a batch animation. And so this does everything in batch basically. It expects an animation file, so we saved it. I can just drag this here. And we need to specify the dimensions of the rendering which we want to create. So let's use the same which we had before. And now let's click on OK, and you see that we get the very same video which we had before, without actually interfering with the renderer at all. So I think this makes it quite easy to just apply the same rendering, the same animation to a new dataset. And by the way, this is also macro recordable, so you can also then animate this step by including it into image.j macros if you want to do so. And there's actually another function that I would like to show you, which is related to that. So let me once more open the interactive animation. And now you can also, by the way, drag and drop an animation file into this window, and it will open up. And now, since we were talking about macros, you can also directly from this animation editor create an image.j1 macro. So I will do it. It creates a self-contained macro, so it also contains an animation text, as you can realize here. And now we can just run this. We don't need the interactive raycaster anymore. We can close it, and also the window here, and this one. And we can just run this macro, and it will create the very same animation which we had before, using the currently active window, which is our original image here. Okay. There we go. So now we have more or less like a point where you have learned quite a lot about 3Dscript, and I think you saw in quite some detail how to use it. But now, recently we have worked on another extension to 3Dscript, because we realize that oftentimes the datasets are big, and you might actually want to work not on a sophisticated workstation, but maybe you are just working at home on your laptop, and maybe you're in home office actually, and you cannot actually access a big workstation, but maybe you need to still create some nice video or animation for a paper. And so we were thinking about how animations can be done remotely. And with remotely, I don't mean like using screen sharing. Of course, you can always do screen sharing, but screen sharing might actually be a little bit laggy. I tried it myself. And so that gets really annoying when you want to see the fine temporal transitions in animations. So the screen sharing is actually maybe not the best, let's say. So we were thinking about how we can actually do this rendering remotely, and this is what I would like to show you in the remaining part of this workshop. So let me close these things here. And so what we developed is basically a client-server architecture. Everything's still implemented in the Fiji ecosystem. So there's a server which does the rendering, implemented as a Fiji plugin, and there's a client which can call the server and doing the rendering, and also the client is implemented as a Fiji plugin. And I think the ideal, more like the scenario for which this is made, is actually, you imagine you have a lab, you have a shared computer which you use for like processing and doing like demanding stuff, and you like sit now on your workspace and you want to access this shared computer and do the rendering there. So we'll now connect via screen sharing to so I will now pretend that the computer that I'm sitting right now is my weak laptop, which is not ideal for rendering, and so I will run the server on a remote machine to which I connect now via screen sharing. So in my case this is called Fourier. So I will just connect it. Here we go. And so here I will start my 3Dscript server, and for doing so I will first start Fiji. And so I will first show you how you can actually install 3Dscript server. So let's go to Help and Update. And let's go to Manage Update Sites. So we need to add another update site here. So I click on Add Update Site. I will call it 3Dscript server. And I will need to enter the URL where this extension can be found. So if you're going to GitHub and you're looking for 3Dscript server, this is where the source code is, and here you also find the instructions for installing it. I will just copy this URL here and paste it in here. And get these changes. So let's restart Fiji. And now you will see that the 3Dscript menu contains two more items: the 3Dscript server, which we'll be using on this remote machine, and the client, which I will then execute from my local machine. Okay, so let's do a server here. And you see it started the server. It starts really fast, so it says it's running. And here we have some window for some log messages. So this is basically what it looks like. There's one more thing which I would like to mention, because normally if you have a shared machine that you are using for that purpose, you don't want to always log in via screen sharing and open the server plugin. So this can be automized, and you can automate it by installing it. Install means here that it will automatically add it to the Windows task scheduler, so that Fiji and the 3Dscript server plugin will be started when the computer boots. So that's only available on Windows. Let's see. So I click on the install. And of course I need to have admin rights to do so. And now let's confirm. So I go to the task scheduler, and you see there's now an entry 3Dscript which will be executed at system startup. And what it does is basically it, you can see it here, so it runs Fiji in headless mode and calls the 3Dscript server plugin. So no magic really. Of course, if you don't want this, you don't need to. And basically you can also uninstall it again. You don't need to run 3Dscript server. It also runs as it is now. And so that's basically all I need to do on the server machine. So I will make this a little bit smaller. We'll still keep it here so that you can actually, let's put it maybe here, you can actually see what's happening. So on my local machine, let me now go back to Fiji. And here I would like to run the client part of the software. So I go to Plugins, 3Dscript client. And now before we started, actually one word about the input dataset. Of course, somehow we need to tell the server which image data it should render. And also the server needs access to it. So we could directly copy the data from the client to the server. But just imagine for a moment the situation like you're sitting at home on your laptop connected over a wireless connection, and you want to upload a huge data set, so that's probably not very convenient. Or maybe even think you're sitting in a cafe, you're connected over a metered network, and you don't want to upload basically a huge file. So 3Dscript server assumes that the file that you want to render is actually already at some central location where the machine can access it. And right now this can either be a shared file system, maybe implemented by your institution, or it can be an OMERO server. So these two options exist. For now, let's use a shared file system. And so I configure my input source, which basically means I select the image which I want to render. And so you see I need to enter URL, a user and a password. So let's see. So you see the folder which I'm currently in here is actually a shared folder. And so in that case, I can just drag it inside this text field. And it will so the drag and drop will automatically convert it to this share notation, which you may know from Windows shares. And so it's automatically converted such that it will work in the end. And then, of course, most shares are secured. So whenever I included this share in my file system, I had to specify some credentials, and the same credentials I need to specify here now. So let me just use my local ones here. Okay. So we have configured the input. Now we need to specify the width and height. I will just leave them as they are. And of course we need a script, and the script is just a text file, so it's not big, so it will just be copied from the client. I will use the one which we created. Download result is something that we don't need, you will see in a second, but more importantly there's run remotely, and this is where we specify on the client where the processing should take place. And so I click it, and here I can select the machine where the processing should take place. If it's the client and the server are connected to the same network, then the service could be detected automatically. That's not the case for me now. My processing machine is in a different subnet, so I will enter the machine name manually. You can also enter an IP address. You can also use more than one processing machine. And I click on OK, and now when I click when I start this here, you can see on the client we see a progress bar which tells us what's actually happening. Right now the server, so what's happening on the server basically. So right now the server is opening the dataset. On the server side we can see there was some warning. The file was not properly closed, so we can ignore this. And then you can actually see what's happening on the server. So this is because I started the server plugin manually, so not in batch mode. If you installed it in the task scheduler, you would actually not see anything. But since I started it manually in interactive mode, you can actually see what happens on the server. And if you're on the client, you still see what the server is doing. So right now it is saving the result, converting it to an MP4 file, and then maybe you remember I did not click download because by default the result of the rendering will just be put in that shared folder. And you see we have now here 3 more files in that shared folder. One's the animation file. We would have needed it in that case because we have it here already, but still. There's a PNG, which would just be a still image. And there's an MP4. And there's an MP4, which contains the animation which we just rendered on the server. So all the hard work was now done on this remote server, and I could have done this basically in a cafe using my laptop. It does not really need a lot of data transfer. The biggest part is probably the resulting video which I downloaded now. Okay. So this is one client, but since we are running an OMERO server in our facility, I thought there must be a much more comfortable way to run a 3Dscript on a dedicated machine. And this is OMERO 3Dscript, which I would like to show you now in the remaining time. So I will close my connection here. I will close also Fiji, we don't need it anymore right now. And so all we need now is a browser basically, and I will go to an OMERO server which I set up for demoing this. So here we go. I don't need to log in, it has a public user. In case you don't know OMERO, so this is the web interface of OMERO, and basically OMERO is basically a software for managing and organizing your imaging data. And in my case I have here some folders. We'll look into the organoids. I have a folder with organoid images. This is what they look like. And so yeah, the cool thing about the OMERO web interface is that it is relatively easy to write extensions for it. And so I wrote one such extension which is called 3Dscript, OMERO 3Dscript, and let's just see what this looks like. So I will select one of these images here, maybe the first one, and now I can right click this. I go to Open With and 3Dscript. And so what you see here is the web interface of OMERO 3Dscript. It's kept very simple, I would say. So basically you see some placeholder panel which will display the animation once it is done. We see a progress bar which will show us the progress of the animation. And we have a text field where we can actually enter some text for doing the animation. And so maybe I will just also here demo this to you. So also the text field here is fully auto completion enabled, so I can say at frame 0, zoom by a factor of 0.8. So I will keep this very simple now. We'll just zoom out a little bit maybe, and then we create some simple rotation. So rotate by 360 degrees horizontally, and we also do the easing, and at the same time we zoom by a factor of 2 maybe, and maybe we also switch to change rendering algorithm to combined transparency. And so I can run this now. Here you can see what's actually happening on the server. So it opened it, it rendered it, it's now converting it, it's attaching it. We'll see in a second, and we get the video here. So I can play it, and you see we get the rotation, we zoom in, all with this combined transparency rendering algorithm. So a very simple script in this case. So whenever I run such a video, this will be automatically saved as an attachment in the OMERO web client. So when you look at this image here and we go to attachments, you see that I have done this quite some time actually. So this was not the first time, but somewhere down here we will have the PNG, which is a still image, and the MP4, and also the script for the animation, all saved as an attachment to this image, and from there I can basically access it from everywhere. And so you can just download this and then copy it to your local PC and play it. But I would like to show you something else. Now we can actually do more things with it, cool things. So I will select now a couple of images here. Maybe let's get 6 is a good number maybe. So let's select 6 of these images here. They have all been imaged under the same conditions as you most likely can guess. And so the OMERO way to getting a link to these images is now by going to this chain symbol here on the top right, and this will actually display a link into OMERO, into these 6 images, and I will just copy this link, and now I go back to the 3Dscript interface, And you can see on the top here, what you see is the title of the image, and right to it there's this edit button. When I click on edit, I can actually select a different image, either by the OMERO image ID or by the link. And in this case, I would just paste the link, which I just copied. And when I click render now, you can see that all these 6 images will be rendered one after another with the very same script, and they will also be placed one next to each other so that I get quite a good overview. So I think this is really neat, because you can imagine you have done some experiment, you have, like, let's say tens or whatever number of images, and what you want to do now is you want to render them and you want to compare them and see what's the difference between different conditions. And with that functionality, you actually see it side by side rendered with the very same settings, and you can directly see whether there's some difference or not. So it's now at the last one, so it opened it, it's finishing it up, and once it's done, there's this play all button, so that you can actually see the video of all 6 at the same time and see their animation. Okay, so this is actually everything that I wanted to show you today. There will be a question and answer session during the conference, so if there are any questions, I'm happy to get them there. And otherwise, I would like to show you some resources. So 3Dscript was published in Nature Methods some time ago, so you will find some information in that paper, of course. Otherwise, there is a 3Dscript GitHub page. That's probably the main entry point into 3Dscript's documentation. So you find it on GitHub, 3Dscript. If you Google for it, you will easily find it. It shows you how to install it. There's a very detailed wiki which basically shows everything that I have shown you today. So it's very complete, I would say. And then the server part, which I have shown you, is also on GitHub. So that's here. And the server part is also published more recently, so last year in Bioinformatics, 3Dscript server, Bioinformatics, which is basically here. So with that, I'm at the end of this workshop. I would like to thank the organizers of the I2K conference. So it was really a huge pleasure last time, and I'm sure it will be a great conference this year again. So I'm really looking forward to it. I would also like to thank all the members of our group at the OICE here. And with that, I would like to thank all of you for attending and watching to the end. And yeah, as I said, I'm happy to take questions in the questions and answer session. And yeah, thanks for watching.